Hello guys, recently I uploaded these two reels on my Instagram page, this one, and today I wanted to just do a little breakdown of these. So let's get started. The files for this breakdown are available on my Boosty page. You can get just these scenes, or you can subscribe to my Boosty and get access to all of those files. So here is the scene file. Okay, I have a basketball balls here and then those sci-fi thingies here. So let's start off by looking at the modeling of this ball. Let's go to the basketball model. I start off with a simple circle, as you can see here. I just rotated this, merged it back, and then I also just up this a little bit, rotated it, and did a soft transform like this. I mirrored this, and then I merge everything together. Next up, I resample it to give it a little bit more points here, and then I use the quad sphere just to have a perfect sphere here, and then I subdivided this quite a lot just to get enough information to array these points. So these points basically are not perfect sphere here, so that's why I'm just arraying them, and I'm giving them a point normals here, and then I'm transferring those point normals back to those lines here. This is going to be used for the sweep node here. As you can see, if we turn this off, we don't get this perfect along the sphere here. So if we transfer those normals, this sweep is going to go around the sphere. Thicken them just to add a little bit of thickness here. Clip them and then mirror this back because I had some problems for this side. So I just clip this and mirror it back. This quad sphere, then I grab it and I boolean this by this, and then I quadro mesh this with these settings here, and I got this nice mesh here. I fuse them just in case, and then in this side I take again from this attribute transfer here, do the same thing basically, just to pick it inside a little bit, give it a sweep here, and I do that just to select those inner points as you can see here. And then if I just promote this group to primitives, I give it a mask here. This is, I think it's not even used, and then in here I just select this middle edge here, and I also create this center seam here. Those seams are used to UV unwrap this sphere. If I promote it back to primitives, I can get these nice edges here, as you can see. And then I used a UV flatten just to give it the UVs, and I used a seam, which is this one. So basically what I did was I promote this group, and I also did a promotion to the edges, and then here's the settings. So I can select those edges. That's it. That's the UVs, and I used a remove UV distortion node, and then also UV layout, so I can get this nice UVs here. Okay, so I subdivided this, and then I gave it a name for the Solaris. I extracted those lines again, poly extrude them, subdivide them, pick them just a little bit inside, and then in the end I get mesh like this, and I just delete attributes, give it to normals, and that's it. So this is the modeling part. So next up we can just dive inside of the render. So I start off with the component geometry node, dive inside, and as you can see, this is just a object merge from that modeling basketball here. Nothing is changed here. And then this is my material library, and then all of my materials are located in here. So this is all of my materials. So I got one for the inner strips, and then for the ball itself. Those are simple materials, so nothing too fancy. The only thing that I did here is, if we just look at the model, let's turn off karma. So what I did was, for this I created a new cop network. I created this pattern here. So this is just a grid. I scattered points and then Voronoi fracture it. I have a pattern like this, and then I used a facet node to basically make those primitives unique, and then insert those chunks here, and then give it a connectivity node, give it a just index attribute for each of those polygons. And then if we go back, we can use a rasterized geometry node. You can rasterize them. It's an 8K texture, by the way. And then if you here, you can import in the index attribute and then just create a random attribute. And what I did was I just multiplied this and then blur it a little bit. These are not even used, I think. Yeah, this is just for the visualization. I just imported those inside of this. I just imported those patterns using a OP. So you can just say OP and then just copy and paste your cop network here. So I just Control C, and then if I go back to the material, I can just say OP and then Control V, and then I will get my shader back. So this is how you can use those cop textures directly without exporting them. This is just smudge texture I used for the roughness, and then I used this color attribute here for the base color. This color attribute is also created in here. So if you look at this here, I just selected those chunks and then added these colors, and then I put this color not inside of the CD but inside of the color 01. Just I don't want it to have a visualization for this, so this is just stored in the attribute here, and then I'm using this later here. So the cool thing here is you can have those component materials here, and then the cool thing, if you just duplicate this, you can make a different set of components that you can later on use in the instancer. So the way that it works here, I just assign those materials one by one, as you can see. So this is the original basket, the black one, and then this is just with the white strips, and then this colorful one, right? And so what I do was in here you can just name those variants here, and then you can use this reference node, and then in here just primitive path, just variants. So if you look at this scene graph tree, I'm not really into this USD stuff, so I can't really explain it in depth. If you use this reference node here, you get all of your variants here, as you can see. You just have to tap this. So if you create a explore variants node here, and then this is let's call this variants collection, right? And then you have to just say explore variants here, and then you can visualize those all of those prototypes, right, that you have. So these would be copied with the instancer. So before those go to instancer, you just have to apply the node explore variants and then select this duplicate variants option here. And then they all go into the instancer here. You just have to say, so basically name this variants collection, and then in here you just say variants collection. So you go inside variants here, and then use all of those variants. Basically with just say star here, and then this instancer is going to be using all of those variants for the instancing. And then the cool thing in here is basically this instancer can use a index attribute as a like a prototype. So if you use the copy to points, you have this variant attribute. So this is basically the same thing. To dive inside, what I did was here, I used this node called planar tiles. This node, I just animated this pattern size here, as you can see. So it just basically creates these quads, and then you can animate these. And then what I did was here, I used a add noise. This is just a float noise. It's animated like this. And then with this triangle, I'm just animating the start. So I don't want to have anything in the start. So I just animated this, and then the end as well. Then I used a node extract centroids. So I just extracted the centroids of each of those primitives, and I also transferred the noise, and then I just set the p scale, so it's not even random. This is attribute randomize here. So let me have it, for example, like this for now. So we're seeing, and then let me just turn on this. So this is what we have so far, as you can see. And then I use this scatter align node here. I use this just to randomize this offset, as you can see. But what I did was I used this noise attribute to basically animate this offset, so it rotates when the noise kicks in. In here I have a attribute randomize, so I just set the initial index to the black and white ones, as you can see here. So it just says max value is 0, so the 0 is, as you can see, this is the 0 primitive is the original one, which is this one. So 0, 1, 2, 3. So this is the ball that is used in here. So I hope it makes sense. And then I had this VOP here. So if I plug this in and then if I just restart the renderer, as you can see, they are changing. So what I did was I had this noise and I have this threshold here. So basically, if the noise is less than 0.1, the balls are by index. So this is the original ones, right? But if it's not, I'm just taking the frame, taking the random number here, and basically I'm just animating this with this modular. So each time this animation gets to 4, it's gonna go back and then repeat itself. So basically this is the animation that it's happening. So this is what drives this animation. And then for those sci-fi patterns here, right? Let me just dive inside of these. What I did was I just imported this back, the basketball model, copied the points. This is just for the visualization purposes. And then for the ball, I just created the box here, which is the same size as the ball. And then what I did was in here, I deleted the orientation and normal because we don't want box to be different each frame, right? And then I deleted the points based by noise, so only where the noise is, those points will be appearing. And then I set the p scale and then I copied those boxes here. Next up, for each of those boxes, I generated the smaller ones, so I just turn this off, which looks like this, as you can see. And then I basically copied the simple sphere just to check the insides, as you can see. And then I just deleted those. So I got something like this. If I look at this, as you can see, where the ball is, basically there is no box. And then I used just noise, animated it, I normalized it. I basically multiplied p scale by this noise. So it's animated as well. And then I use this attribute VOP. So basically what I did was I checked the center of those points, and then I'm just multiplying the p scale. So I'm making them smaller, as you can see. So where near the ball, they are gonna be smaller, and you can adjust this parameter. And then I also delete some of these based on noise. And at the end, we get something like this, as you can see. So as I said, nothing too fancy in here. It's just animating. And then I used a SOP import just to import those backs, and those are rendered as a hairs. In here I just said treat as a light source. This is useful for karma, so basically it kind of adapts it and it's easier to render, easier to get less noise. And then the shader is pretty simple. It's a glass shader with the emission here. That's it. And then everything goes to the renderer, just simple top and bottom lights and one H. And also I use this background light here. I just turn off this diffuse multiplier and specular multiplier, and everything goes to karma. So that's pretty much it for this. For the duplication effect, what I did was I had the setup. Is actually kind of complicated, so I'm not gonna be going through too deep into this setup, but basically I have this initial ball here which does nothing, and then I have this rigid body sim. What I'm saying here is I'm just duplicating those based on this trigger attribute here, and I'm creating a new box. So the cool thing is that it just kind of like wiggles, and then it creates duplication of itself, which kind of looks smooth. And so that's pretty much it. That's the setup. So I'm not, as I said, I'm not gonna go deep into this, but if you wanna learn more about this, you can like find scene file. And then I'm just importing those points back, caching them, retiming them, and then this is just for the visualization. So I'm basically taking those RBD points here and then importing those back to the Solaris. This setup is the same as the previous one, but inside of the instancer, what I'm doing here, basically I'm taking those points back to the instancer. And then the problem was here is that if you just add this random index attribute, what's gonna happen is that the index will change whenever the new point basically spawns, and that's the problem because the instancer will flicker. So as you can see, the ball here is, for example, black and white, and a couple frames later it's gonna become like this color. That's the problem. So what I had to do is I had to just take this name attribute and what I did was I just converted this to the ID attribute. So this ID attribute is not relative to the points, so it's just the same for each of those. So it doesn't change over time basically. And then I just based on that calculated this index, random index. So it's custom, and then I cast this to the integer. That's pretty much it. For the spawning, the same thing basically. The only difference is that instead of the noise, I took the age attribute of those points. So basically, when my point gets spawned, it has age of 0, and when it's just basically when it's just born, I'm gonna have this, and then I'm just gonna disappear. So that's pretty much it. Everything else is the same basically, and all of that as well goes to the renderer, and that's pretty much it for this breakdown.